Alright guys, welcome back. This is the second part of the similarity triangle. So as we talk about the first one, we know that the only case of similarity will be angle, which is the easiest one, the easiest case in the whole history of mathematics. Yeah. So now let's talk about the second case, which is side, s. Basically, in this case, all you have to do is just try to find ratios, which is the fractions. And you can do either way. Either you take your ratios k will be the big one over the small one, or your ratios k can be small one over the big one here. How can you form that? Well, all you have to do is just take the side corresponding and put them in there. The most common mistake that you will have will be 1 doesn't understand that any fraction, any number is a fraction of itself over 1. For example, 2 can be understood as 2 over 1. That's really critical part, guys. Second, lost track on the side. Sometimes like when you get tracing side and then you get just one tiny mistake and you will slip it. And we forgot that, which is also a critical part. Number 3 will be having negative ratios. Again, measurement cannot be negative. It's impossible. Last but not least will be assumed stuff. Do not assume things. Never ever assume things. So now let's go over the example number 3 we have here. Now suppose that we have those two triangles right there, QPR and the triangle TSU. So you want to know whether they are similar or not. So all you have to do now is you have to form the ratios. K equal to small one over big one, or if you want, you can do the ratio of big one over small one, and it doesn't matter. You still have the same solutions, but it's just different ratio K. On the test that will specify that how the ratio is going to look like. But if they don't ask for it, you can do whatever the heck you want. So now, since I'm Asian, let's do small over big one here. So now, for the first ratios, I'm going to pick the small one over the big one. Obviously, this triangle here will be a small one, and this triangle right here will be the big one. As we know, the ratio will be small. Since we say that we want the ratio will be the small one over the big one, therefore, let's name it. Alright? Let's suppose that I start here. This is my starting point. The top part here is my starting point here. So then, if I want to follow along this direction here, my first side will be QP over TS. Should be QP over TS. Oops. Now QP over TS will be 3 over 6. If you simplify that, it should give you 1/2. Should be. If you have a question about it, you seriously need to use a calculator. Alright, after the first ratio, the second ratio will be what? Follow that path. So now at P, now we're going to go to R. Same thing here. As for the next path will be PR over SU. PR over SU will be 4 over 8. Simplify that, you will have 1/2. Then you follow the path. Now you go back up. And you go back up here. So it will be RQ over UT. RQ over UT. Just down here. That will be 5 or 10, which is exactly the same similarity. Which is when you simplify that, it will be 1/2. Once you have those, you can say, well, I got these bunch of fractions here. I got QP over TS will be exactly the same as a PR over SU. Also, it's going to be the same with our Q over UT, which is 1/2. From there, you have to say, you have to say what triangle are similar to what triangle. Very simple. If you are lazy, just like me, all you have to do is just pick the first order pair here, QP, QP, and the TS down here. Put it right there, and then put the last letter in, and that's how you get the similarity triangle. How you get the name of that. Also, please remember, write down the reason why they are similar. Without this, I would take points off. This doesn't matter that you have everything right, but if without that, I would consider the whole thing wrong, because you can tell that whether they are similar or not. Alright, the last example for side will be example number 4. And let's suppose that on example number 4 here, you have two triangles, CD, excuse my notes, CDE, with the measurement very big number here, 32, 30, and 35. And then you have tiny one here. You got FG, FG, and H here with 25, 24, and 28. Similarly, let's call this one small, because obviously the size is too small, and it's going to be the big one. They ask you whether they are similar or not. We don't know yet, but we know that since we have the measurement right there, we know what we have to use. In this case, it's going to be the ratios, because we have all the measurement here. Now, by eyeballing it, we know that this measurement right here will be the smallest. Also, this measurement right here will be the smallest, right? So let's try to form a ratio between them. Let's see how it goes. So let's suppose that in this case we want to make our K ratio is the big one over the small one. So let's see, with 30 over 24. Let's use the calculator to simplify that. Or if you don't like to simplify it as a fraction, you can do a decimal. It literally doesn't matter in this case. 30 over 24 will be 1.25. Similarly, of the second part, this right here will be the second largest. Let's make a fraction out of it. There 2 out of 25. It's going to give you 1.28. And last but not least will be the biggest, which is 35 over 28. .25. Now, do we have the same ratios? Well, this and this is exactly the same, but this is not. From there, we can say that no, they are not similar. They're not similar whatsoever. If you have a question, feel free to send me an email or send me a message through the Remind apps, and I will happily reply within 30 minutes time frame. We will continue in a second. third part.